Hello everyone, welcome back to the channel Unlock Concepts, where every concept becomes simple. In today's video, we are starting with one of the most interesting and important chapter, that is probability, and we will be using this in our day-to-day life every day. We often use words like chance, likely, or possible. For example, what is the chance to rain? Or in beginning of a match, toss a coin. So this all comes under the topic of probability, and we use probability to calculate these chances in a mathematical way. In this session, we will be learning the basics of probability and the concepts behind the probability, like starting from experiments, events, and we'll be moving to sample space, impossible and sure events, and then we'll be using some practical examples with coins, dice, and playing cards. And you'll be having some other videos which will be solving some problems in one video, and we would be even doing some board based questions in another video. So please stay tuned to the channel. So now let us start with the probability in this video. So the first one is introduction to the probability. So probability is a measure of chance of an event happening. So it is widely used in daily life like weather forecast, sports, games, insurance and exams, etc. So for example, you go into the Google and type as weather near me. Then you'll be getting a tab which will be showing you precipitation chance. It might be like you'll be having 70%, you'll be having 10%, or you'll be having 0%, or you'll be having 100%. So these are chances to rain. So then we'll be having this one into the consideration, and these all are nothing but probability. So the probability to rain on a particular day shows us is the weather. So now probability of an event. So probability of an event is simply nothing but number of favorable outcomes by total number of outcomes. So this is only one formula which is used in your complete chapter, and you will be solving problems only using this one formula, which is very much important if you ask me. And then the value of probability always lies between 0 and 1. If a probability is 0, then it is zero event. If it is probability is 1, then it is sure event. About these we will be seeing in later on in this video. So simply probability is just a measure of chance. If in exam, if anyone asks you what is probability, then you simply tell them as it is a measure of chance of an event which is happening. So that's it. So now let us get into some technical concepts of this probability. So now sample space. So what is sample space? Sample space is set of all possible outcomes of a random experiment. Okay, so just understand this. Each possible result is known as sample point. See, we have, if you roll a dice, roll a die, then these all are probable outcomes. So if you roll a die, you might get 1, you might get 2, you might get 3, you might get 4, you might get 5, or you might get 6. So this completely 1, comma 2, comma 3, comma 4, comma 5, comma 6 is your sample space. And each element in this are known as sample point. The number of elements in the sample space are the total number of outcomes. So in this formula, we have seen this total number of outcomes. And now this total number of outcomes in this rolling a die is 6. That is 1, 2, 3, 4, 5, 6. So total are 6. So let us see some examples. If you roll a die, you will be having 6. If you toss a coin, you will be having only two outcomes. One is head and one is tail. If you toss two coins, you'll be having four outcomes. That is head, 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 tail, tail, head, and tail, tail. And if you take some cards, you'll be having 52 total number of outcomes. So simply a sample space is a set of all possible outcomes of an experiment. Or in simpler words, sample space is number of elements in sample space are equal to the total number of outcomes. Now, let us come into some random experiment. So, what is random experiment? An experiment whose outcome cannot be predicted in advance. So, this is known as random experiment. For example, let us toss a coin, let us roll a die, let us draw a card from a pile of cards. So, we cannot tell that it is a it will if you toss a coin, it is not certain that you will be getting always head. If this happens in between of a cricket match between like Kohli and Dhoni, if Kohli is playing and Dhoni is playing, if Kohli tosses a coin and then Dhoni needs to tell that it is a head or tail. If he knows in forehand that it is always head, then every time Dhoni only wins the toss and Kohli loses the toss. So we can simply tell that this tossing a coin event is a random experiment. So let us go into event. Possible outcome or a group of outcomes of a random experiment is known as event. Example, getting an even number of dice, getting a red card from pack of 12 cards. So key point is an event is a subset of sample space. So just understand my main thing now. So what is a random experiment? It's tossing a coin. Okay. So now what is an event? Okay. Getting head. Okay. So now tossing a coin is a random experiment which is done, and getting a head is an event. And now our main aim is to find the probability of getting a head when you toss a coin. And this tossing a coin gives us a sample space h comma t, and these two are total outcomes. And getting head, you will be having only favorable outcome is 1. Therefore, the probability of getting head is 1 by 2. So this is completely thing which you will be seeing in your probability. Okay. So first one, an experiment is done. What is that? Tossing a coin. So what we need to find the event? Number 2, getting ahead. So now for that, what we need to do? We need to understand that sample space of an event, of an experiment, that is h comma t. So total number of outcomes are how many? 2. So this is the fourth step. Now using this total number of outcomes, so how many favorable outcomes we are having? Only one. So this is fifth step. Now what is the final step? Calculating the probability. So if you take any problem in the probability, you need to have these all steps in order to get your correct answer. First one is finding the experiment, second one is finding the event, third one is finding the sample space of that one, fourth one is total number of outcomes, fifth one is favorable outcomes, sixth one is applying the formula. So this is the major thing in the probability. Okay. So now let us get into the next point. Experimental probability and theoretical probability. So what is experimental probability? So this is this one and this is this one. So based on actual experiments or observations. Okay. So but this is based on reasoning and mathematics but not actual experiment. Probability may change when the number of trials change. Assumes equally likely outcomes. The more the trials, the closer to get theoretical probability. Experimental probability is based on observation, not theoretical. Okay, so now let us understand the main thing behind this one. So now to simply understand this one, so I would be writing a formula for both experimental probability and even for the theoretical probability. Probability of an event equal to number of times event occur by total number of trials. So now this probability of an event is equal to favorable outcomes by total outcomes. So to understand this, we will be seeing an example now. See, sir. So now we have an example of experimental probability that 6 appears 23 times when we roll a die 100 times. So what is probability based on this one? Number of times an event occur. So what is an event here? To get 6. Okay. So how many times did we roll a die? 100 times. So how many times did we get 6? 23 times. So therefore the probability is 23 by 100. So now let's come into theoretical probability. It is find the probability that if we roll a die once, we get 6, the same event. So it is 1 by 6. So this do not change, but this changes. If, for example, if a person rolls a die, he got 623 times. If B person rolls a die, there is no guarantee that B person will also get 623 times. He might get 44 times, or he might get 50 times, or he might get 0 times. Who knows? So that's why experimental probability is based on that particular instance. Only that particular instance or experiment. Okay, but whereas theoretical probability is same always. So I hope you have understand now these things. So experimental probability is based on actual experiments, and probability may change when number of trials change or number of times we do the experiment changes. So for the first person also, if a person only did once, he got 23 times, and again he tried another experiment of rolling a die 100 times, there is no guarantee that he will be getting again 23 times. So this is how the experimental probability works. So this is out of our imagination and everything. So now we will be focusing on only this theoretical probability in this class 10 mathematics. Okay. So now let us get into some next thing, that is equally likely events and not equally likely events. Equal events that are having same chance of occurring are known as equally likely events. For example, if you toss a coin, what is probability of getting head? Sample space is h by 2. So, so probability of h is 1 by 2. Probability of tail is also 1 by 2 because you are having h once, tail once. Okay, so 1 by 2. In the same way, rolling a die. What is the probability of getting 1? 1 by 6. 2, 1 by 6. 3, 1 by 6. 6, also 1 by 6. So these events are known as equally likely events. And now we have some other events like events where some outcomes are more likely than others. See, we have a bag. You are having some balls in which we have 9 red balls, hit one blue ball. If you want to pick up a ball from that one, what is sample space? Sample space is red, 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 red 9 times and one blue. So what is probability of getting red? Total is 10. How many reds? 9. Whereas probability of getting blue is 1 by 10. So the probability of red and blue is not equal. So these events are known as not equally likely events. So this you will be getting in some 1 mark questions in your examination, like what is equally likely events, what are non-equally likely events, and what are differences between them. So if you consider here, you have both 1 by 2 only. Whereas if you consider here, we have 9 by 6 and 1 by 10. So they are not equal. So simply we can understand that equally likely events have fair chance for both. I'll be explaining this with an example. Not equally likely events have a biased chance. So now let us get into one important question which I want to tell it to you. Okay, so we assume we have a cricket match. Okay, so this is you, this is your friend. So you need to decide who is gonna bat first. So now what is the general thing which we need to use is tossing a coin. Okay. So when we toss a coin, so if you gave a coin to your friend to toss it, so he tosses a coin and you will be telling it as either head or tail. And if it is head, if you call it as head, then you win if it is even head. And if you call it as head but it is tail, then your friend wins. So now my question is, so tossing a coin is fine. So now you're playing a gully cricket match. Okay, you are having only a die with you. You're not having coin. Okay, so since you're not having coin now, you need to roll a die. So, for example, you rolled a die. If you roll a die, then what happens? Your friend will call as 6. So, what is sample space of die? 1, comma 2, comma 3, comma 4, comma 5, comma 6. So, if you roll a die, then your friend called it as 2. So, the probability of your friend winning is 1 by 6. Probability of you winning is 5 by 6. So simply this event is equal likely. This event is biased because here either you and your friend is having equal probability to win the toss. Whereas here your friend is having less chance and you are having more chance to win the toss. So now my question is what condition must be okay, what condition must be kept so that both have equal chances to win. So now my question is you have only a die. What condition must be kept to have you and your friend to win the toss with equal chances? So answer to this question you'll be seeing in a short video or in the next video. So try to think about this and comment down. So now let us get into the next topic, that is elementary event. An event that consists of only one outcome is known as sample space. Each outcome in the sample space is elementary event. Example, rolling a die, getting a 3 is an event. Tossing a coin, getting head is an event. Picking a card, getting ace is an event. So these three are also known as elementary events. Simply understand my thing. An event that consists of only one outcome of sample space is known as an elementary event. If you toss a coin, you have H comma T. This H is one elementary event. This T is one elementary event. So probabilities of sum of probabilities of all element events in sample space E is known as 1. So what is probability of getting head? 1 by 2. Probability of getting tail? 1 by 2. That is 2 by 2. That is equal to 1. So an elementary event is nothing but it is an event which can occur and also present in the sample space. So now let us get into impossible and certain events. An event that cannot occur in random is known as impossible event, certain event. Probability of an impossible event is known as 0. Such events have a no favorable outcome. Example, tossing a coin and getting 3. rolling a die and getting 7, drawing a card and getting a card number 15. So what is the sample space of a die? 1, comma 2, comma 3, comma 4, comma 5, comma 6. So what is an event? Probability of getting 7. So what is total? 6. So is 7 present here? No, 0. So probability of getting 7 is 0. So this is nothing but impossible event. It is also known as zero event. Now a certain event. An event that is guaranteed or happened to happen in a random experiment. Probability of a sure event is one is exactly opposite to that one. Such events have all outcomes as favorable. That means tossing a coin, getting either head or tail. So sample space is h comma t. So total is 2. Head or tail 1 plus 1, that is equal to 2 by 2, that is equal to 1. So getting a number less than 7, 6 by 6, 52 by 52, that is equal to 1. So this is nothing but impossible and certain events. So now complementary events. For any event E, the event not E is complement. Together, E and not E covers the entire sample space. P of E plus P of not E equal to 1. Simply, for example, let us have a sample space of tossing a coin, h comma t. Probability of head is what? 1 by 2. Probability of not head is what? Not head means except head, anything can have we can get. So that is t. So probability of t is probability of t, that is equal to 1 by 2. So the sum of these both is equal to 1. So this is the formula. Okay. So this is how we'll be using. So drawing a card. So getting a red card is 26 by 52. Getting a black card or not a red card is 26 by 52. So 1 by 2 plus 1 by 2, that is equal to 1. So this is also an important formula which you will be using to solve the sums. So now let us understand some basic things which we need to understand in order to solve the probability sums easily. Okay. So first one is coins. We need to understand if you toss a coin, how many outcomes, how what is the sample space if we toss a one coin, how many sample space if we toss two coins like that. So tossing a coin is an random experiment. So one coin you will be having two outcomes, that is h comma t. Simply remember this formula 2 power n. That means 2 power n outcomes you will be having. So 2 power 1, 2 what? That is head and tail. 2 square, 2 power 2. That is 4 outcomes you will be having. Head, 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 tail, head, tail, tail. 3, 2 power 3. That is 8 outcomes. Okay. Tossing a coin simultaneously or one after the other gives the same sample space. Keep this point in your mind because this will be useful while you solve some word problems or application based problems, word problems in your next videos. Tossing a coin simultaneously or one after another gives the same sample space. For example, probability of getting two heads with two coins. So what is sample space? Is this one. So two heads is 1. So probability equal to 1 by 1 by 4. So at least one tail. We'll be having one tail one tail, another one tail. So probability equal to 3 by 4. Okay. Now let us take into dice. So when you take this dice, we have 1 to 6 faces. So one die, you'll be having 6 outcomes. Two dice, this is also same. 6 per n is the formula. Two dice, you'll be having 36 outcomes. Like 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, etc. And then each outcome has equal chance 1 by 6 for one dice, 1 by 36 for two dice. So probability of getting a 4, that is sample space is equal to 1, 2, 3, 4, 5, 6. Therefore probability equal to 1 by 6. Probability of getting an even number. So this is hint for previous question which I have asked regarding equally and not equally outcomes. That is equal to, so 2, 4, 6 are favorable. Total equal to 3 by 6. That is equal to 1 by 2. Every time this probability fraction need to be written in simplified form. Okay, you should write this, simplify, and write the answer. Even you can convert it into decimal form as 0.5. Anything is fine. Now, probability is sum of numbers equal to 7 with 2 dice. That means sample space we will be having. So, total we can tell that possible events are 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 3, okay, 5 comma 2, 6 comma 1. So these are the possible events. So now let us get into this cards. So cards also a simple thing. We have 52 cards in which you will be having 26 red cards, 26 black cards, and then you will be having four suits, that is hearts, diamonds, clubs, spades, okay, and you will be having 12 face cards, each of four, okay, four jacks, four queens, four kings. So you can see here simply four jacks, four queens, and four kings. And A also is A, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3, 4, 5, 6. Each. So you'll be having 13 cards of each suit. So total 13 into 4, that is equal to 52 cards, and total aces are 4. So simple. A probability of getting a red card is 25 by 26 by 52 is 1 by 2. Probability of getting a king is 4 by 52 is 1 by 13. And simply you can find out. So now let us get into summary. Okay. So the concepts unlocked in this video. So number one, what is probability? Is a measure of chance of an event. It always lies between 0 to 1. There are two types of probability: experimental probability, theoretical probability, and this is important which we use in solving sums. When we are having some random experiment, event, sample space, elementary events, likely events, likely occurring events, non-likely occurring events, impossible events, sure event. For impossible event, probability equal to 0. For sure event, probability equal to 1. And some point basics, some die basics, and we also learn some cards basic. And this is an important formula which I said: probability of an event plus probability of not occurring an event is equal to 1. And finally, the formula probability equal to favorable outcomes by total number of outcomes. So this is the theoretical concept of probability. If you understand this video very well, and I can tell you that you can easily solve the problems. So anything to solve a problem in probability, number one, find the sample space. Number two, what is the event? Number three, likely things in the event. Number four, writing the formula. Number five, simplifying the formula. So that's it. So these are the main things which we need to keep in our mind. And then this is a quick quiz. So please comment down your answer. Just simple questions. A coin is tossed once. What is probability of getting a tail? A die is rolled. What is probability of getting an even number? A card is drawn from pack of 52 cards. What is probability of drawing a king? So these we have even seen in the video. So please just comment down if you do not remember the answers. Just solve and just write. This is just a test for yourself, and hope so you liked the video. Please like the video, share and subscribe the channel and share it to your friends so that they will be also learning this one. So now this is the main thing. So first is, what is this one? So first is random experiment. Next one is event. Next one is finding the sample space, find total number of outcomes, finding the favorable outcomes, applying it in the formula. So this is an important slide. So you just take a screenshot of this if you want. So this is the end of the video. So we will be even meeting you in next video, in which we will be solving some exercise problems, and then you will be also getting another video in which we will be solving some board based question problems with the PYQs and some expected problems. And so probability is the first video which I am doing. So if you want, so which chapter you want in the next video, so please comment down so that I can do that one and help you in learning mathematics. Thank you.